This video is on functions, yay or nay. We're still putting it all together. We are determining if these graphs are functions or not, and then we're going to determine the domain and range of the graphs. So in this example, we have a graph. We want to go through vertical lines. So if I draw a vertical line, I'm only hitting it once. But on this vertical line, it does cross into two parts, but because this point right here, so there are 2 points here, this one is open. That means it's not actually touching this value. That means the vertical line will only cross this coordinate completely. The same thing happens at these two. This coordinate is not actually being used for the x, but this one is. So it will only cross this part of the graph, not both. So that means that this is actually a function. For the domain, I'm going to find my point to the farthest left, which in this case is an arrow, and to the farthest right, which is an arrow. I want to see if I can go from blue to blue without picking up my pen. So if I start from this blue along the graph, I come to a stopping point. I have to pick up my pen. That means that this is a discontinuous graph. This could potentially have to use a union to unite the 2 parts or 3 parts of our domain and range. What we need to look for is if there is an x value that is not being touched. So from this blue, we know that the blue will keep going since it's an arrow. We know that this is a negative infinity, and this will be a positive infinity. So no matter what, we will have those 2 parts in our domain. We need to know if we have to write another value because it's not going to be included from negative infinity to infinity. When we go to this stopping point, the x value, we would need to keep going. So we would need to keep going from this x value right. As long as there is something solid anywhere in the gap between this solid coordinate and this solid coordinate, then we'll be fine. From here, I have a solid point, but then I have a connector up here. I have another part of a graph. This is solid, but this part's not. This x value still has something solid on it, even though it's on a different part of the graph. As long as this x value has something solid, it's good. That means I can just jump to this one without having to break it. I can keep going to the right and I'm still on something solid. Then I come to this spot, which is not solid. But I look on this line. Do I have anything solid? I do. That means it's good. I don't actually have to break anything. Then I keep going and I can reach my blue. What this means is because I did not actually have to stop to find something else solid or to go to a brand new solid part going towards the right. I can actually jump up to here and I can continue going right and never go left to right without hitting something solid. I did have to jump up, but that's not left and right. If I can jump up and still keep going solid to the right, I'm okay. I jumped down and still kept going solid to the right. That's okay. So our domain was actually not broken. Our domain is still our negative infinity to positive infinity with open brackets. So we're going to do the same thing for the range. Our range, the lowest point is again that arrow, and our highest point is again this arrow. So we have our negative infinity and our positive infinity. So we know we will have that. But we need to see if we can go from pink to pink without stopping. we know that we're going to have to stop here. So we need to know, can I go to the left or right? Can I jump left or right without breaking the solid? The domain, I could jump up and down and then continue going right. So I need to see if I can jump left or right to continue going up. If I jump, nowhere on here is there a left or right that I could jump to. That means I would have to jump up, and I can't do that without breaking it. So this will actually break. My range breaks because I have nothing to jump to over here. So this range stops at 1. Then I can jump to the next solid point by going up. So the next solid point after this one would be here. This is at a value of 2, so I have to start it at 2. Then I keep going up, and I will hit the pink. The range broke because I could not jump anywhere on the left or right to continue being able to go up. I had to break it to start over. That means that our range has to be united with our union. We do have the negative infinity, but then it has to stop at that 1 with a closed bracket. Then I need to unite these two because there's a break, so I use a union. And then it starts over again at that 2. And it's a solid 2, but then it will continue going on to positive infinity. What that means is that there is nothing solid between this 1 value and this 2 value. There's nothing on this graph that is solid. That's why we have to have a union. For the domain, there was something solid from this point to this point going right. I could go right and still hit this solid aspect because I was going right. And then I could come back to here and keep going right. That's why our domain was not actually broken, because these connected the solid and not solid part. Because we still had something solid, we were able to keep our domain. This was a discontinuous graph. This next example, look to see vertical line. If I draw a vertical line here, it will cross this graph twice. Therefore, it is not a function. It still has a domain and range. It is just not a function. So our domain, our farthest point on the left is this point right here. And if we go to the right-hand side, we have 2 points here. So I could circle either one of these or highlight either one of those because they're both open. The farthest point to the left, the x value, is that -2. And the farthest on that right is that +4. Our domain, we can go from blue to blue without breaking. Our domain will be that -2 to that +4. It is solid at the -2, but it is open in both of these locations on that 4. So it's an open bracket. Our range, we want to go from the lowest point. So the lowest point on this graph is this open circle. And the highest point will be this open circle up here. For the y values, the lowest value down here is that -4. And that highest y value is that +3. If we can go from pink to pink continuously, we're good. So pink along the graph, still on something solid, to pink. That means our range is from -4 to +3. the -4 is open, and that 3 is also open. On the next example, look for a function. So our vertical line hitting only once, still only once. So this will be a function because the vertical lines will only cross once. Domain. The farthest left is going to be this arrow. The farthest right will be this arrow. We do have a negative infinity, and we do have a positive infinity. From blue, trying to get to blue, we have to stop here. Now, we have to look to see if we have to break this or if we don't. So from this blue, I want to keep going right, but I can't go right if I'm not solid. So I need to see if there's anything I can jump to up or down first. If I'm on this line, there is nothing I can jump to up or down to be able to continue going right. That means it must break. This part is broken. So it actually will stop at this +2. And then the next solid part after this +2 is this +3. So it is broken. We have to unite the domain. Our domain, we do start with a negative infinity, and we are able to continue it until we get to that 2. So it's open on that negative infinity, and it is open on the 2 because it is not solid. But we have to unite the break, so we union, and then it starts back over at that +3, which is closed, and it goes off for infinity to the right, to positive infinity, which is open. So we united the domain on this one. So when we look at our range, we find the lowest coordinate, which is this point right here, and then our highest, which are the arrows. Both arrows are pointing up, so it does not matter which arrow I use. We want to go ahead and put this number down here. This is at a -8, and this is at a positive infinity. So from pink to pink, from pink going up, still continue, so it stops here. I want to keep trying to go up, but I want to see if there's anything I can jump to left or right. And I want to get to that pink, so I want to try and go right. If I can jump to something solid, I'm okay. I can jump to this solid. So now I can keep going up and I will reach the pink. That means I am actually connecting these two. These are what connect the range. So there is actually no gap between those. So that's good. So our range will keep going. I do not have to unite anything because it's already done for us. Also, so I could have highlighted this arrow as well in pink. And I would have gone from this pink to this pink without stopping. So I still would have been fine. I would not have had any gaps. So our range, our smallest number is that -8, and it will go to that positive infinity. So let's close on the -8 and open on the positive infinity. On this last example, we looked for a function, so vertical line test. This is our graph right here. It's going to keep going that way. The vertical line will only cross them once, so this is a function. It passes the vertical line test. Our domain. The farthest left is going to be the arrow that's over here, and the farthest right is going to be the arrow that's over here. So we have negative infinity to positive infinity, and we can go from blue to blue without breaking. So our domain is negative infinity to positive infinity with open brackets. Our range. The lowest y value is here because it doesn't go below that. Our highest y value is this arrow that's up here. what we need to know is that what is this number, and will it be open or closed? Will it be solid or not solid? So this is at 1, 2, looks like it's at positive 3. That's that y value. And this one will go to positive infinity. Now this is an exponential graph. The exponential graph forms an asymptote. This dotted line here, I'm going to do it in green. This is actually an asymptote. An asymptote is where the graph, it's a line where the graph approaches but doesn't touch. So that means that 3 will be open. Our range will go from 3 to positive infinity, but they will both have open brackets because that horizontal line here is not crossed and it's not touched. So it is a function, our domain and range. We were able to go from pink to pink without breaking, so it was a continuous graph. So again, always look back to see, can you go from if you're using the colors, if you can go from your color to your color without breaking. If you have to break, you need to see if you can jump. So if I want to go up, I need to see if I can jump left or right before I continue to go up. On this one, I need to see if I am trying to go towards the right. I want to keep going towards the right-hand side. If I can jump up or down to get something solid again. So I can jump for going to the right, I can jump up, and then I can continue going to the right because this part was already solid. So anywhere on here is still fine because I already have solid. And this would keep going to the right, and then I could jump again down in order to go right again because I never went to the right and went over a blank spot. I did have to, for my range on this one, I did have to go up over a blank spot. That's why we had to unite them. So you gotta know which way you're going and which way you're allowed to jump to not break the graph.